Hi everyone, I'm Cheryl. In this problem, we're asked to find the center of mass for a system of points. And in this particular case, I think I'd like to draw a little picture so I can get a sense of what's happening. I know that at the point 2, 2, I'm going to have a mass point of 5. So let's mark that down on my Cartesian plane. I also know that I'll have a mass point of 1 at negative 3, 1. So that's going to be right about here. And a mass of 3 at the point 1, negative 4, which is going to be right here. Okay, so in order to find the center of mass, I'm actually going to have an ordered pair. And I calculate that ordered pair by finding the moment about the y-axis, dividing it by the total mass, and then the moment about the x-axis, and dividing it by the total mass as well. So I need to do some calculations before I can plug these values into my ordered pair. So the first thing I'm going to do is get the total mass. So my total mass is simply going to be 5 plus 1 plus 3. So 5 plus 1 plus 3, that gives me a total of 9. The next thing I want to get is the moment. Let's do the moment about the x-axis first. Okay. If I do the moment about the x-axis, remember what I'm doing. I'm taking the product of the mass and the directed distance from the x-axis. Well, let's take a look at just one of these points. If I'm looking at the directed distance from the x-axis, I'm actually looking for the y-coordinate of that point. So that means for my first point, I'll be taking 5 times 2. For my second point, I'm going to be taking 1 times 1. And for my third point, it will be 3 times negative 4. And with a little arithmetic, I get 10 plus 1 minus 12 for a moment about the x-axis of negative 1. I'm going to do a similar thing now to find the moment about the y-axis. Now again, what I'm looking for is the mass times the directed distance from the y-axis. So again, using this point as an example, the directed distance from the y-axis will actually be the x-coordinate of my ordered pair. So for my first point, I'll have 5 times 2. The second point will be 1 times negative 3. And the third point, 3 times 1. For a total of 10 minus 3 plus 3, or 10. I now have all the information I need. I just need to plug it into my formula. So, to get the center of mass, I need to take the moment about the y-axis, which is going to be 10, and divide that by the total mass, which I calculated to be 9. For the y-coordinate, I need to take the moment about the x-axis, which is negative 1, and divide that by the total mass, which is 9 again. So it turns out that my center of mass is the point 10 ninths and minus 1 ninth. Now let's see what that looks like on my Cartesian plane. 10 ninths is just a little bit bigger than 1, and minus 1 ninth is just below the axis. So it looks like that, right about here, is going to be my center of mass for this problem. I hope that was helpful. Thanks.